Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in the Department of Computer Science and Engineering and Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about graph theory. So graphs are going to be used to model the pairwise relationship between the objects, and generally this network can be represented by a graph, and many practical problems can also be easily represented in terms of graph theory. So when it comes to the history of this graph theory, so the origin of graph theory can be tracked by back to the Euler's work on the cosine bridge problem, so which was identified in 1735, so which led to the concept of an Euclidean graph. And this study of the cycles by Thomson P. Crickman in 1806 to 95 and William Hamilton 1805 to 605 that lead to the concept of Hamiltonian graph. So the graph theory, so which was invented in 1735, so mentioned in Euler's paper on some bridge of cosine brick. And the problems, what is that? So what should be walk around all the 7 bridges without crossing the bridge? And so this thing, the problem can be solved by designing a graph here. And Crickman and Hamilton is the other kind of persons who are going to be introduced Hamiltonian cycles in normal graph here. And this graph theory can also be used in electronic circuits as well, which was invented by Kirchhoff, and which is going to be solved as electronic circuits also. The very first thing is that graph is nothing but a collection of nodes and edges, which should be denoted by G is equal to V of E, where V should be the set of vertices on points or nodes, what we call, and then E should be what we called as edges, links and arcs between the pairs of nodes. And the graph size parameter should be represented by n is equal to mod v and m is equal to mod e. So the graph is nothing but a collection of nodes and edges where you can able to represent it as a set of v comma e. So where v should be the set of vertices and e should be the set of edges, and graph size should be the mod v and then mod e. That should be the number of vertices in the graph and number of edges in the graph. So what is a vertex and edge here? So the vertex and node is nothing but the basic element and should be drawn as a node or a dot. And this vertex that usually denoted by v of g or v, or can also be represented as v of g. And so the edges is also called as an arc, and it should be the set of 2 elements here, and where you can able to draw the line connecting these 2 vertices called as vertices and endpoints. And edge set of this graph is normally denoted by E of g, or E I can also represented as E suffix g. And neighborhood or adjacent is nothing but the nodes which are going to be connected by means of an edge. So what we called as a neighbor vertex or neighbor node, and normally it should be represented as n of v here. So what is a vertex and the edge in the graph is that, so vertex is normally a basic element of the graph, and normally I can able to represent the form of a node, or I can able to represent the form of a point here. And this should be what we called as the edge, and this one what we called as arc as well. And normally these vertices should be represented as v of g, or also can able to represent as a set v or v of g. So it should be nothing but the set of vertices. And edges in the graph what we called as E of g, or can able to write E or E suffix g. So the edges, what we can able to write as E2, E3, E4 and E5, E4. And so let us consider the graph here. So in this graph, the number of nodes in the graph is 6 and number of edges should be 7. And how can I able to represent this? So it should be the set of vertices and this should be the set of edges. So I can able to write it as E1, E2 and E3, E4, E5, E6 and 7. Like this also I can able to present, or it should be a set of 1, 2 and then 1, 5, like this also. A neighborhood of 4. What are the neighborhood of 4? That should be 6, 3 and then 5. So this should be the neighbor vertices of the node 4. And next we're going to see about edges type. So there are different types of edges like directed, undirected and weighted edges. So undirected means that so the distance between the two cities and then friendships and all, and then directed means that should be the ordered pair of nodes. There should be a source and there should be a destination or target. Then it should be called as directed edges. And weighted means that so the edge which is going to carry the weight should be considered as weighted edges. So the edges means that so if I'm going to have a graph, so these edges what we call it as undirected edges, since there is no directions in between them. And similarly, if I'm going to represent the directions here, then it should be treated as directed edges. And the edges which is going to carry the weights, then it should be called as the weighted edges. So like this we are going to be represent different types of edges in the graph. An empty graph means that so which may not have any kind of edges, then it should be called as empty graph or null graph. So that means no nodes and obviously no edge. And simple graph means that so a graph which may not contain any loops and then multiple edges, then I can able to call that graph as a simple graph. So normally some of the graphs is going to have self loops like this, and then multiple edges may also be there, some of the graphs. So this kind of graph may not be called as a simple graph, so since it is going to have the multiple edges and self loops and all. So the graph which is said to be no self loops and the multiple edges is called as simple graph. So a simple graph, so the degree of Vi should be denoted as 2 mod E. And next one is directed graph. So here the directed graph means that the edge is going to have the directions, and some of the graphs may also have loops like this, and then multiple arcs also. So here in the directed graph, if I'm going to have the edge like this, so 1, 2, and this should be almost all similar to the 2, 1 as well. So whereas in directed graph, the 1, 2 may not be equal to 2, 1. So this kind of what we call it as a directed graph here. And next one is weighted graph. So weighted graph is a graph in which the edge is going to have associated some weights. How I'm going to show that. So this is the graph. In this graph, I'm going to hold some of the weights. So this one what we called as weighted directed graph. And this one, so this one is also have another kind of graph which is going to represent the weights in terms of decimal, so it should be also the weighted. So this one is undirected one, and this one is weighted directed graph. And next one is bipartite graph. So what is this? So here the vertex set is going to be divided into two sets, v1 and v2, such that the edge uv belongs to e implies that, so the one of the u edge, one of the vertex should be v1 and v should be v2 set. Okay, so like this. So this is the one kind of set of vertices v1, and this should be another kind of vertices v2. So what I can able to call it as, so ABCD. So this is the normal set of edges of the graph. So if I'm going to separate like this, A, C, E, F and B, so like this I segregate the vertices into two subsets, and I'm going to draw the edges in between them. So this kind of graph, what we call it as a bipartite graph. So in the bipartite graph, the vertices is going to be divided into two subsets, and the connection is going to be mapped between the one vertex of the one graph and the vertex of the other set. And normally trees, so already know that what is the tree, should be the collection of nodes and edges. The undirected graph is considered as a tree here. Suppose if it is connected and does not contain a cycle, and the two nodes have exactly one path between them. Suppose if I'm going to represent a tree like this, so every tree become a graph, but graph may not become a tree here. So this is the tree actually. So every tree like this. So every tree may also become a graph also. Suppose if I'm going to connect this one, so this may not become a tree since it is contained the closed cycle or contained the cycle. So what is a subgraph here? So vertex and edge sets are subsets of G, so that should be a supergraph of graph G, and that contains G as a subgraph. This vertex set and edge sets are the subsets of G. So where the supergraph of the graph G is the graph which it contains G as the subgraph. So in this one, so this is the given graph here. So in this graph, I'm going to consider three vertex. So this is also a subgraph, and I'm going to consider this one is also a subgraph, and this one also considered as the subgraph. And next one is that adjacency matrix. So normally the graphs are going to be represented in two types of notations, like adjacency matrix and adjacency list, and then incidence matrix. So what is this adjacency matrix here is that it should be an n-dimensional matrix based on the number of vertices. Normally this graph is going to be filled either zeros and ones, so such that if there exists an edge in between the two vertices, I can able to represent as a 1 here, and if there is no edge in between them 1 and 7, so I can able to represent as a 0 here. So normally this matrix only fills with zeros and ones only. So when it comes to this incidence matrix, so whenever there is no edge, so normally this incidence matrix is going to consider only whenever directed graph is going to be considered here. So let's take an example like simply A, B, C. So this is a simple graph. So how this adjacency matrix is represented here is that 1. So I have an edge from A to B, so that's why it should be 1, and A to C 1. So remaining 0. There is no edge from A to A. Similarly, if I'm going to consider B here, so I have an edge from B to A and B to C, that's why 1 and then 1, so it should be 0. And for C to A and C to B, so it should be suppose if I'm going to consider the directory graph like this, so how this matrix should be represented here is that, so A, B, C, D. So in this one, so I have edge from A to B and then A to C, and B there is no edge, so all are zeros here, and for C also there is no edge, and D to B and then D to C. So this should be the incidence adjacency matrix here. So if I'm going to consider what should be the incidence matrix, so whenever the incoming edge is there, then actually I'm going to represent it as -1 in this case. That to be mapping with the vertices and edges. So see this incidence matrix. So in undirected graph, so this incidence matrix should be represented as zeros and ones only here. So whenever I'm going to get this, so I have an angle graph, and this one, so how the incidence matrix is, so I'm going to consider the vertices on the rows, and the columns I'm going to consider like this: AC, AB, AD, so E1, E2, E3, E4 and E5. So I have an edge here, so in this one, so I'm going to map E1 and E4 should be 1, remaining all zeros. So I'm going to consider B, E2, E3 and E4, so that should be 1, so remaining all zeros. And for C, E1, E1, E2 and E5, so it should be, and for D it should be E3 and E5, so remaining all zeros. So normally this one is going to be mapped with the number of vertices here, and this should be the edges here. So the incident matrix is going to be mapped again as the vertices and edges, and that should be filled with zeros and ones. So how are we going to fill this one inside in case of directed one means? So these values are going to be filled with zeros, 1 and -1 comes into picture. Suppose if I'm going to fill like this, the directed graph. So for A it should be E1 and E4. For B it should be so E2 and E4. And C3 should be 1. So remaining should be 0 here. So why? Because this -1 is appearing, so these two edges are going to be incident on B, so that's why it should be reflect on B. So what I'm going to say that is, so if I'm going to it should be -1. So whenever there is an edge that is leaving from the V, then it should be filled with 1. Similarly, if I'm going to consider C here, so for C the two edges are leaving E2 and E5, so that should be 1, and one edge is coming to the C, so that's why it should be -1. And for D, The two edges are incident on this, so E3 and E5, so it should be -1, and remaining all should be 0. And next one is that another kind of representation is that adjacency list. So what is this adjacency list here? So the directed graph, so the edges list are going to be displayed. So 1, 2, and then 1, 2 again. So 2, 3, and 5, 3, 2, 3, 2, 5, and 4, 5, and 5, 4, like this. Then I have to consider this nodes. So that should be the set of vertices. And for 1, so what are the nodes that are connected is that 2. So 1, 2, 1, 2. So this should be this adjacency list of 1. And for the node 2, what are the edges that are connected? 2, 3, and 2, 5. So that should be 3 and 5. And for 3, only self loop is there. And for vertex 4, it should be 3 and 5. And vertex 5, it should be 3 and 4. So like this, we are going to be construct the adjacency list of the matrix. Suppose I'm going to construct like this. So I'm going to consider the vertices here. And what are the nodes that are connected from A is that B and C. And for B, it should be A and D. And C, it should be A and D. And D, it should be B and C. So what I'm going to be represent this adjacency list for weighted graph here. So normally weighted graph means that the edges is going to carry the weights. So while listing this adjacency list, so have to be represent the edge what is going to be connected along with the weight value. So for the when, it should be the node that is connected is 2 and weight value is 1.2. So for 2, it should be 4 and the weight value is 0.2. Like this, we have to be represented here. So I'm going to construct one more graph here. So this is the given graph, weighted graph. So how the adjacency matrix is going to be presented. So A, B, C, D. So for this one, so what are the nodes that are connected here is that, so A to B, so that should be 2, and B to A is also 2, and B to D, and B to C also. So if I'm going to consider C here, so that should be A to C, and D5, and D6. So like this, we are going to consider the adjacency list for the weighted graph. So next one is that classification of graphs. So normally, so there are different types of graphs. So what should be this? So this should be the connected graph and isolated vertex. So the two vertex are said to be connected if there is a path between them, and isolated vertex means there is no edge that is coming or incoming from the vertex. So here in this one, the 4 is the what we called as isolated vertex, and this one what we called as connected graph, and this may not be connected graph if I'm going to consider. So if I'm going to make the connections like this, then it should be connected graph. And the vertex which is said to be alone what we called as the isolated vertex. And adjacent nodes, so the two nodes are said to be adjacent if they are connected by an edge. Suppose if there is an edge, U, V belongs to E of G, we can say that U and V or the adjacent nodes are neighbors. So an edge with 2 or more end vertices are same, so that should be called as a loop or self-loop. So the edge, the vertex whose edge is starting and ending with the same, then should be called as a loop or self loop. The two nodes are said to be adjacent if they're connected by an edge. And next one is, what is the degree of the graph? So the degree of the graph is that, so the number of edges that are connected to the vertex is said to be degree of the graph. Suppose if I'm going to consider 3, so what is the degree? So 3 and then 2. So what is the degree of 2 here? So this one, and this one. So the degree of 2 is 2. For 1, so what is the degree here? So the degree of 1 is number of edges that are connected with one vertex is 2. So for 6, it should be 1. So how are we going to calculate this degree in case of directed graph? So that means in degree means the number of edges that are incident on the vertex, and out degree means the number of edges that are leaving from the vertex, and total degree is going to be calculated from in degree plus out degree here. So for 1, so what is the in degree of 1? So the two vertices, two edges that are leaving from 1, so that's why the out degree is 2, and in degree means the no edge is coming to the incident only 1, so that's why it should be 0. And next one, suppose what is the in degree of 2 here? So the in degree of 2 is 2. So because the two edges are coming to the vertex 2, and number of edges that are leaving is 2. So that's why it is 2. So next one, 3. So number of incoming edges is 1, 2, and then 3. So the in degree is one more thing is that 4, and out degree is 1. Then next one is, what is the path or walk? So walk is nothing but a path in which the edges and nodes are going to be repeated. Okay, and a walk is said to be closed whenever the source and destination should be same here. And trail means no edge is going to be repeated. Next, path. So what is the path? Is nothing but a sequence of nodes. Then the no vertex can be repeated, and the closed path is the path which contains the cycle, and the length of the path is going to be calculated. The number of edges that are visited in the path, that should be the length of the path. So what is the path from 1 to 6? So P1 equal to 1 to 2, 1 to 3, 3 to 4, and 4 to 6. This is one of the path. So similarly, I can able to get from 1 to 6, one more path I have been able to construct. So that should be 1 to 5, 5 to 4, 4 to 6. So that one is that. So I can able to go 1 to 5, 5 to 4, and then 4 to 6. One more path I can able to construct here is that. So 1 to 5, 5 to 2, 2 to 3, 3 to 4, and then 4 to 6. So 1, 2, 3, 4, 5. So these are the paths, various paths that can able to reach from 1 to 6. So what is the path that should be closed? Source and destination should be same here. So once I started from, so closed paths that may appear here is that the starting is 1. So 1 to 5, 5 to 2, 2 to 1. And 1 to 5, 5 to 4, 4 to 3, and 3 to 2, 2 to 1. So these are what we called as the closed paths here. And what is the cycle means? So cycle is nothing but the closed path where the source and destination should be same. So the cycle is going to be represented by C suffix k, where k should be the number of nodes in that cycle. So in this one, so the closed path is going to be connected with the 3 vertices. That's why it should be represented as C3. in vertex is 4, so the number of vertices that forms a cycle is 4, so that's why C4, and here it is C5. And what is the shortest path here? So shortest path is the path between the two nodes that has the shortest length. So the length is going to be defined as the number of edges, and the distance between the two vertices is nothing but the length of the shortest path between them. And the diameter of the graph is nothing but the length of the longest path between the pair of nodes in the graph. So these are the various terms and we have to be remembered in the graph. So here the degree of this graph can be calculated as the number of edges that are incident on the vertex should be treated as in degree, and the number of edges that are leaving this vertex should be called as the out degree. And how are we going to calculate this total degree means? So what should be the degree of 1? That should be 2 plus 0, that should be 2. And similarly, what should be the degree of 2? It should be 2 plus 2, 4. And similarly, what should be the degree of 3? That should be 4 plus 1, 5. So like this, we are going to calculate the degree of the graphs. And similarly, there should be different types of representations. So first one is that adjacency matrix is one of the way of representing the graph, which is going to be filled with zeros and ones. So whenever there is an edge between the two vertices, that should be represented as 1, otherwise it should be 0. And next one is that incident matrix. So here it should be also be filled with ones and zeros, and it can also be filled with -1. Adjacency list is other kind of representation where we are able to represent the graphs in the form of nodes. And in case of weighted matrix, it should be weighted adjacency list. So have to be filled the node along with the weight value. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.